Okay, so we have to compare data using histograms. So a guided practice question. Type in. The typing speeds of the students in two classes as shown. Use a graphing calculator to create a histogram for each data set. Then describe the shape of each distribution. Compare the distributions using either the means and the standard deviations or the 5 number summaries. Justify your choice. So before we go to Desmos to do our histogram, there's something we're going to just mention. Now, for standard deviation, we're going to have two different formulae. And when we use the calculator, so we have one for a sample, and we're going to see this as SX. So this is when we have a sample that's been taken, and we'll have this here, which is going to be using, so we're talking about the population. So we'll also see X bar, which is for the mean. And then we'll see our other. So we'll see the 5 number summaries. So these are going to be our minimum. We'll have quartile 1 median, which is the same as quartile 2. We'll have quartile 3 and our maximum. So we're going to use either of these to compare, and we need to justify our answer. Now we can use a calculator to put in our data, but to start we're going to have a look at using a graphing calculator. So we're going to use Desmos to create the histogram. So just going over to Desmos. So when we create data sets, so I have got A for our first data set, and I've put them in square brackets. And the second data set I've called B. Now we can give them any variable, but we need these square brackets either side. So we've got 24 elements in our list. Now to create a histogram, so we go to functions, and our stats gives us different options. We're going to go to the dist, and then we can choose histogram. So I don't actually want it here. I need it on this line here, so we're going to do that again. So histogram, and then it says data set and bin width. So now we need to decide what is going to be the width of our data. So we could choose from 20 to 25 as 5, so we can say that we'll choose it as 5. Our first data set is going to be using A, and I'm going to center it, instead of centering it, I'm going to put it to the left. So let's just check our minimum value. So minimum value of A, this is 22. We've got our quartile, so quartile, which is going to be A, 1, and this is at 32.5. We're going to have our median, which is A, 33.5, our quartile 3, so this is going to be A, 3, 38.5, and our maximum value of A, which is at 45. So that's going to take our 45 to here. Now, if we did the same, so we're going to look at our data set. So we've got our data set B. So what do we know about our distributions? Let's have a look at, so we've got histogram, and this is B. And we're going to keep it as 5, and we'll keep it as to the left. So let's compare both. So first of all, let's take this one off. So looking at the distribution, so we can see that where would the, let's actually work at the mean for A as well. So the mean for A, so 35.25. So we can say that this is actually symmetrical, it's actually in the middle. But we have got some higher values over to the right. If we look at histogram, our second one, so on this one here, again, let's have a look at our values. So for histogram B, our minimum value of B, so 21, so our value is here. Then we have quartile, so B, 1. So this is at 31. So our median for B, so this is at 34. So it's just before the mean. Then we have our quartile 3. Just typed. There we go. Let's get rid of that. On quartile B, 3. Better. 38, and our maximum value for B, so we've got it 46. So our histogram, so both of them are values, the mean more or less in the middle, so we can see that. So the distributions are actually symmetric, so we need to look at the mean and the standard deviation. So we have two different types of standard deviation, as we said. So if we look at our stats, there's two different options. So the first one, STDEV, this is our normal standard deviation. So standard deviation for A. And then if we go back, we'll have STDEVP. So this is the population. So we can put STDEVP, population of A. So this is going to give us 5.04. And if we do the same for our histogram B, so we've got standard deviation of B, and then for the population, so DEVP of B, so we have 6.26. So looking at our deviations here, okay, we can see that they're actually quite close for both data sets. So if we want to use our calculator, okay, so you'd be looking at an older calculator, you would be looking at mode and 3 or 2 for stat. So using stats mode, if you're using, as I've got a class whiz, so if you're looking at the class whiz calculator, you can choose your menu, number 6, number 1, and then you can type in your data set. So if we have a look at just doing that, so 43, and then we have 38, 31, 33, 34, 45, 32, 33, 38, 36, 40, 22, 36, 34, 39, 31, 35, 33, 37, 38, 28, 29, 39, and 42. Okay, so once we've put it in our table, we can press cancel, option, and number 2. And this is going to give us our data. So we have, so if I just move this across over here, so let's move it a little bit more so we can compare. Okay, so we have a mean 35.25, which is what we said. So if you go down here, we can see on the calculator, this is going to be our population deviation, 5.04. And then if we go to our next page, 5.15, this is our normal standard deviation, 5.15. So we could do this for both data sets. So if we're using our calculator, so we have a minimum value, our quartile 1. So we have the median. Now we would just go to cancel, do another table, and to compare the value for the second one if we were to do it on the ClassWiz. So let's just come back to here. So to conclude, we're going to say that the distributions, they're symmetric, and using the means and standard deviation, you can see that they're very, very similar. So the third period students, this is the ones we have here, in like our orange, they are on average, they had a higher typing speed than the sixth period students. So supporting the conclusion that the third period students have a higher typing speed, and we can see that this is shown here on our histogram.